Let's solve exponential equations in the form of a times b raised to the x by using logarithms, again focusing on the change of base theorem. The four equations that you have, we cannot write right now in logarithmic form until we get the base raised to the x isolated. That's going to require us to divide each equation by its a. Let's begin with our first equation, which I'll label a. If you divide by both sides by 22, you will get 47 raised to the x equal to the fraction of 523 over 22. Your answer is a fraction, and you may be tempted to convert it to a decimal. I'm going to suggest you don't, because you're going to end up rounding that number most likely, and then you're going to take a log of a rounded number and produce yet another rounded number. Just deal with a fraction. You can handle it. So convert 47 raised to the x equals 523 over 22 into its log form, and just say log of 523 over 22 to base 47 equal to x. If you're going to type it into your calculator and you want to use, let's say, the common log of the problem, and you write 523 over 22 and divide that by the log of 47, the way I might do it on the calculator would be log 523 divided by 22, parentheses, then we'll hit divide, and then we'll hit log of 47. Now I'll close the parentheses, now I'll hit enter, and you'll come up with an answer that is approximately 0.8230 when we round that fourth decimal place. Let's define our second equation to be b. Originally had 42 times 13 raised to the x equals 2. Now you should have 13 raised to the x equals 2/42. I'm going to write log of 2 over 42 to base 13 equal x. If I want to use my change of base theorem, I'm going to go ln 2 over 42 divided by the ln of 13. We'll go to the calculator. ln of 2 divided by 42. We'll close the parentheses. We'll divide that by the ln of 13. I'll hit enter, and I'll come up with a value of negative 1.1870. C. If 20e to the x equals 1530, then we'll say e to the x is equal to 1530 over 20. I don't have to use the change of base theorem. I can just manually go ln 1530 over 20. And we come up with an approximate answer of 4.3373. Let's make the last equation D. 21 times 10 to the x equals 56 cannot be directly converted to log form until you divide both sides by 21 and then rewrite it as 10 to the x equals 56 over 21. We can now use a common log. We'll just go right to log 56 divided by 21, and we come up with an approximate answer of 0.4260. Before I conclude, let's be clear. I've had a focus on using the change of base theorem. I have intentionally ignored for most of the videos the option of using log base if you have it on the TI-84 calculators. They will be found if you have the math print option. So, if you go to math and you go to the bottom of the list and you find log base, you can do these problems without doing necessarily the change of base theorem. If we go back to A, I don't need to do log divided by log. I could have just gone log 47, move over to here, and type in my fraction 523 divided by 22. Hit enter, and see I still get the 8.230 that I expected. I could have gone back to math, find my log base, see that my second equation, I could have just gone 13 and then put 2 over 42 here, hit enter, and confirm that I got negative 1.870. It is very handy to have a feature like this so that you can compute logs of any base directly. However, If you're ever in a situation where you have just a single based log, maybe it's a common log, maybe it's the natural log, you can still evaluate because you now know how to apply the change of base theorem and still be able to evaluate any log.